Hello, this is the second part of the introduction to Greek mathematics, and today we're going to focus on the Pythagoreans. Thales and the Pythagoreans were the progenitors of pure mathematics. Uh, we're going to focus on Pythagoras here. We talked a little bit about Thales already in the first one. Pythagoras, his dates are about 570 to 490 BCE. Pythagoras the person, and he was the leader of the Pythagoreans, who were a communal group, perhaps a math cult, of mathematician mystics. Sounds to me like a pretty cool thing. They believe that all is number, and we'll talk about what that means. The mathematical accomplishments of Pythagoras, in other words, the Pythagorean theorem, could actually be those of the group itself or other mathematicians within the group. The inner circle was called the learners, or in Greek, the mathematikoi, and that's the origin of the word mathematics. The followers were the listeners, or the akoustomatikoi. There was a prohibition against beings. And again, not again, but I haven't talked about this yet, but were they holders of souls? That's what some people think the Pythagoreans thought. Or was it because of Favism, which is an infection of fava beans, which can be deadly? Now, the Pythagoreans believed in the transmigration of souls. In other words, when we die, we went into other beings, an animal, maybe vegetables, maybe plants, maybe a fava bean. And at the same time, the Pythagoreans were thought to have been vegetarians, yet it's alleged that they sacrificed an ox. This was in an ancient Greek satire where the Pythagoreans were depicted as sacrificing an ox when they figured out the Pythagorean theorem. Okay. So here's a picture of fava beans, and you can see those holes, and those holes, the school of thought that believes that Pythagoreans believe that once we die we go inside a fava bean. That school of thought said, oh, it's because of the holes. But again, remember, these beings were subject to an infection, and that infection could be deadly. So it could be that the prohibition against beans was just good, sound public health. So here's a cock and bull story. Again, a story that's not true. And we'll come back to this. So it's from classicalwisdom.com, and we'll see more about them. The Pythagoreans outright worshiped their philosophical beliefs, going so far as to sacrifice an ox after discovering the 47th proposition of Euclid. That's the Pythagorean theorem. Then two paragraphs later from classicalwisdom.com, a central tenet of the Pythagorean belief system was the transmigration of the soul. That included the transmigration of human souls into the bodies of animals. It is perhaps for this reason that the Pythagoreans strictly forbade the consumption of meat, resulting in his followers becoming some of the earliest known vegetarians. Is it just me, or is there kind of a fundamental contradiction going on here? You sacrifice an ox, presumably to eat it. That's what you do when you sacrifice an animal. But at the same time, they're vegetarians. Okay. Classical wisdom indeed. So I talked about all as number, and we need to know, to at least to a Pythagorean, what a number was. A number was a positive whole number, and what we call the natural numbers. But in some senses, one wasn't even really a number. More about that later. To us, a number is much broader and includes positive and negative whole numbers, zero, fractions, irrational numbers, any number on the number line. Now, just to recall, a rational number is a ratio of whole numbers. An irrational number is a number that is not a ratio of whole numbers. So here's an example of a rational number, or where one occurs. Vibrating strings dampened in certain ratios of whole number produced harmonies. This is something the Pythagoreans were aware of, and was thought to have been one of their one reason why they thought all was number. Kepler, the astronomer in the 1500s, took a similar notion and wondered if the planets were distributed in harmonic ratios, and if so, did the planets produce the music of the spheres? Think about frets on a guitar. Those are harmonic ratios that produce sounds. So were the planets like frets? Were they distributed like frets on a guitar in a ratio that produced the music of the spheres? Again, that was the question that Kepler asked. So the Pythagoreans also had something called a doctrine of odd and even, and we'll talk in class about how they probably viewed odd and even numbers, but it's pretty much what we do. 2, 4, 6, 8, even, et cetera, et cetera. So even plus even is even. Odd plus odd is odd. Even plus odd is odd. Even times even is even. Odd times odd is odd, and even times odd is even. These were things that Pythagoreans were thought to have proved, and they comprise the doctrine of odd and even. Okay. So again, number mysticism. I said one wasn't a number, but maybe a better way to say that was one is a special number. It's the source of all numbers. It creates all numbers. You just keep adding 1 to itself, and it creates all the whole numbers. So 2 is considered a female number, and under this thing that 1 is not a number, the first number. 3 is the male number. Guess what 5 is? It's the number of marriage. 4 is the square, and the number of justice and squaring of accounts, so it's probably the number of accountants as well. Now, all is number, that included geometry. We have something here called polygonal numbers. And so even shapes were numbers. You can see here we have those dots arranged as triangles, squares, pentagons, and hexagonal numbers. And you can think of these atoms as forming these shapes. You're connecting the dots, so to speak. Anyway, more about this in a presentation. Now again, what they thought that if you took any 2 physical magnitudes and measured them against each other, you obtained a ratio of whole numbers. So if things weren't whole numbers, they could be ratios of whole numbers. Now the very fabric of nature was revealed through number. Again, we just had music, shapes, and so they thought the world was sort of comprised of some fundamental level of numbers. Number is at the seat of creation. So as 1 created the numbers, so numbers create the world. Okay. So a little bit more about this is the notion of a common unit. So here's an example. I have 2 lengths, A and B, and if I put them in a ratio, I'm going to get a ratio of 2 whole numbers. And the greatest common factor of A and B is going to be the common unit. So here's an example. Let's say A is 20 and B is 15. Then A into B as 20 is to 15, as I express in that equality. And if you cross multiply, you get 15 copies of A and 20 copies of B are going to line up perfectly. So that's what it means to be commensurate. They line up perfectly. Now the common unit of measure is 5, since 5 divides both of those. And again, any 2, if the Pythagoreans believed if you took any 2 magnitudes, they would be a ratio of whole numbers and have a common unit. That common unit could be 1, or it could be a different number. Okay. So the modern equivalent to this belief is that all numbers are rational, are actually, to be specific, positive rational numbers. And equivalently, given any 2 magnitudes, A and B, the fraction A and B is a ratio of whole numbers. Okay. But we know that's not true. So looking at the interval 0, 1, I've got 2 copies. In the second copy, you see a little red section. I'm trying to sort of get us to visualize a really tiny subinterval. Now, in that interval, there's going to be infinitely many rationals and irrationals inside it. Between each pair of rationals lies an irrational, and vice versa. Between any 2 irrationals, you're going to have, in fact, infinitely many rationals. Now, we can also measure these using something called Lebesgue measure, which is a component of measure theory, which is something you learn in advanced real analysis. And if we take the measure of all the irrationals between 0, 1, that length is going to be 1, the entire interval. Rationals, its measure is going to be 0. So if we're thinking about that, if we stack all the rationals next to all the irrationals, all we're going to see is irrationals. The rationals will be such a small stack we won't even see it. Okay. So back to commonwisdom.com and the story of the dangerous ratio. It's a stormy day on the sea off the coast of Greece. The date is around 520 BC. Fighting for his life, the man is heaved over the side of a boat and dropped into the open water to die. His name is Hippasus of Metapontum. His crime? Telling the world a mathematical secret, the secret of the dangerous ratio. The murder of Hippasus is a matter of legend, but the secret was real, and certainly dangerous enough to the beliefs of those who knew about it. It was a secret owned by the school of Pythagoras. These early Greek mathematicians, Pythagoras himself was born around 569 BC, were obsessed with the significance of whole numbers and their ratio. The Pythagoreans' motto, carved above the entrance of the school, was all is number. The square root of 2 isn't 1 because 1 times 1 is 1. And it isn't 2 because 2 times 2 is 4. It's something in between. This wasn't a problem for the Pythagoreans. It was obviously a ratio of 2 whole numbers. They only had to figure out what that ratio was. At least that was the theory. But after more and more frantic attempts, a horrible discovery was made. There is no ratio that will produce the square root of 2. It simply can't be done. It's what we now call an irrational number. Not because it's illogical, but because it can't be represented as a ratio of whole numbers. This was what sent the Pythagoreans into such a spin that they may have sacrificed poor Hippasus. If you believe that everything is constructed from whole numbers, it is a terrible shock to discover that there's an everyday number, a real-world number like the diagonal of the square that doesn't fit your picture of the world. It's a nightmare, and from one from which the Pythagoreans would never really recover. Okay, again, from classicalwisdom.com. Here's a dramatic rendition of the discovery. And on the next page, you see a portrait of poor Hippasus. Okay. I don't know where to begin here. But I'm going to try. Okay. There's so many things wrong with that. First of all, if it was a secret, how did the Pythagoreans discover it? If they know about it, it's not really a secret. And if mathematicians aren't the kind of people that really kill people for knowledge, the Unabomber was a physicist, not a mathematician. Keep that in mind. Mathematicians like to share their results. The mathematicians I know like to be proved wrong and say, look, I found out what I believed in wasn't true. Isn't that interesting? Okay. So there's so many things wrong with that story. But be that as it may, there's a grain of truth into it. It is thought that somewhere along the line, there was a discovery that the square root of 2 was irrational. And you've seen that proof in Math 101, no doubt, especially if you had me. It was the, when we proved the square root of 2 is irrational. Okay, and we'll go over that proof in class. So in any event, the Pythagoreans are somebody after them. Oh, the Pythagoreans also, to say that they never recovered is in some ways not true. As we're going to see, you could draw a line of Pythagorean influence through the Greeks to today. So we'll get to that. So again, to the Pythagoreans, if something wasn't a number, it was a ratio of whole numbers. And then somebody along the line discovered that wasn't so. So there were numbers like the square root of 2, the square root of 3, not the square root of 4, which are not expressible as whole numbers. Think about this. How would you express those? How do we define them? We define them in terms of an infinite series of decimals. There were no decimals back then. You saw sexagecimals. There doesn't seem to be a good theory of infinity. The Greeks thought about things never ended, as I'm sure other people did too, but not a theory of mathematical infinity that was practical, the way that ours is, in the sense that it allows us to describe what a repeating decimal is, for example. Now, how would this inability to define something except by what it wasn't affect mathematicians who want to define everything precisely and constructively? Now, we'll talk more about this later, but I want to talk about the influence of the Pythagoreans on ancient Greece and, by extension, us. So a little bit, here's Pythagoras. He was supposed to have been born in Samos, which, as you can see here, is off the coast of Greece. Here's ancient Babylon over here, and here's Egypt. He spent a lot of time and settled in Croton, Italy, which is over on it's on the heel. It's not in Sicily. Sicily's over here. It's just kind of on the kind of on the heel. So it's in Greater Grecia if you ever go to southern Italy. Um, one can draw a line from Pythagoras to Plato, and then to Euclid, and then through to us. And I don't mean just mathematically. Um, Plato has had an elevated view of mathematics, and again, that's thought to be influenced by the Pythagoreans. He had a belief in the soul that again thought to have stemmed from Pythagoreans. And some people think that his Republic, one of his greatest philosophical works, is a debt to the Pythagoreans. Some of the ideas in there are thought to have stemmed back that far. Now, there were later day Pythagoreans, such as Archytas, who lived, as you see, he lived a little. He died. He was born before Plato and died. Died when Plato was about 40. Um, and so maybe and Plato visited Archytas, and so it's thought that Plato learned about the Pythagoreans from him. And after the death of Pythagoras, about 490, it's thought that the Pythagoreans may have scattered all over the Greek world, as we've seen, which was quite extensive, and others might have stayed settled in Croton. Okay. Um, again, I want to talk about Philolaus a little bit. He was a philosopher that was influenced by the Pythagoreans. He may have been born in Croton. He now lived in Tarentum, which is Toronto, which is now called Toronto. It's in southern Italy. It's not very far from Croton. He wrote a treatise on the Pythagoreans, and again, that didn't survive, unfortunately. He was thought to have taught Archytas, and Philolaus is also mentioned in Plato's Phaedo. And so the idea is that Pythagoras taught, or not, no, he was born after Pythagoras. So the Pythagoreans taught Philolaus, who taught Archytas, who taught Plato. Okay. Again, a little bit about Archytas. He was born also in Toronto, and he became its ruler, and he was called a tyrant. And to us, a tyrant means something different. To them, it was an absolute ruler, but one who ruled, at least it's thought, ruled with the will of the people in mind. So more like a monarch that that seeks to seeks to do well by his people than a tyrant who's only ruling for himself or herself. Now he absorbed Pythagorean political beliefs, but maybe not all its religious and mystical beliefs. He studied mechanics. That's how the forces in nature work. Some think his work is a heart of one of the books of Euclid's Elements. We'll talk more about those, but Euclid wrote a compendium of 12 books, which sort of summarize much of the undergraduate knowledge of mathematics. He was a teacher, perhaps, of another mathematician, Eudoxus, who was also a student of Plato. He's thought to have been a friend and a tutor of Plato. And again, this would have allowed Plato to have studied the Pythagoreans. And some people call him the last Pythagorean, him meaning Archytas, not Plato. Okay. Now, a little bit of the influence of the Pythagoreans on Plato. There's a belief that mathematics put one in touch with absolute truth. That's a belief that Plato had, and that's very Pythagorean. Now, he founded the Academy in Athens. We saw a picture of that. That had a saying on its wall, something along the lines of let none who are ignorant of geometry pass through these walls. And so back in the ancientwisdom.com, where they talk about all this number being on the Pythagorean school, people, I think he's just confounding that with the Academy in Athens and making stuff up. And then, since Aristotle was deeply influenced by Plato, even though he, charted out his own path, and Euclid was also thought to have been, influenced by Plato and Aristotle. So you can draw this line from Pythagoras to these philosophers who influenced mathematics. So we have that Pythagorean line to Euclid, and Euclid certainly influenced mathematics for the next couple of centuries, millennium, as hopefully we'll discuss in a way that makes sense. But also, the Aristotle and Plato, just their philosophy really informed a lot of Western thought for, again, millennia. And so if their thought came from the Pythagoreans, or at least not came from it, but was influenced by it to some degree, then we're going to see influence of the Pythagorean thought in in sort of our institutions and some of our some of the cultural beliefs that seem to be prevalent today. So again, it's the Pythagoreans, even though the people in Pythagoras died out, I think it's really wrong to say that their ideas and influence died out, because they were extremely influential in the ancient Greek world. And since ancient Greek culture was very big influence on Western culture, eventually it's an influence on us. Okay, so here's something that sort of plays that plays on this influence of the Pythagoreans. This is called the School of Athens, and it's by Raphael. And you see the person in the middle that looks old and wise. I think that's Pythagoras. Somewhere there's a concordance about who everybody is supposed to have been, and I think that's supposed to be Plato. But all these people are figures from the ancient Greek world, and it's a painting that the artist Raphael painted. So that's one influence. So I thought I'd like to sort of end today a little playfully with the Pythagorean fractal. We don't associate ancient Greeks with fractals, so I thought it might be fun to make that connection. So we start with a square, and then we're going to put two smaller squares on top of it. And you notice that looks like an equilateral triangle, but that's actually a right triangle. So really right here is going to be a right triangle. Right here. That angle right there. Okay, and then on top of these two things, on top of this square, you put another, you put two more squares and two more, and you keep doing that over and over again. And what you get is a tree, and it begins to turn back on itself. And you can see this link is not gonna work, so I'm gonna skip that. But finally, if you keep going, you get this fractal, the Pythagorean fractal. So you can see that Pythagoras lives today in fractals. Okay, thank you very much. That's all I have.